I want to talk about the replication consistency guarantees. And what I have summarized here is what I think is true, and Casey basically agrees with the most important point. In order for our system, we have this expectation that replication be reliable, and I think that essentially means transactional and consistency, or at least apparently so. We currently seem to have a two-level system, and the bucket index, the bucket index operation and operation, and the ingest operation that triggers it are journaled. Which is fully transactional, so that if for some reason we can't log the operation, the operation to delete an object, we don't delete it. And that's, so insofar as it goes, that's perfect. For what people expect for consistency or replication. However, the full replication relies also on storing a data log entry at that point, which is best effort. If that data log entry isn't updated, it may not be. It may or may not be. There's a potential problem. It may or may not surface, but there's potential at that point of a stall in replication, because even though the operation that's to be replicating has been reliably journaled, we rely on the data log entry to point to the shard that needs to be checked for and synced. And what I basically conclude at this point is that's sort of as things are currently set up. That's basically. That's basically irreducible. If it's in some situation, it could be due to a bug, but it doesn't have to be. It could be due to some sort of cluster or environmental error, whatever. Cluster partitioning, something like some various things. Some set of bucket replication streams could stall, and that stall could be indefinite. Now, it is the case that they're fully recoverable. So someone can run bucket sync run or further ingest on that shard will definitely continue the replication for it, and that's good. But we don't, but it's not guaranteed when or if ever that would happen. So we have a kind of an algorithmic problem. It seems like we would like to solve this in order to have replication be reliable the way ordinary people think of that. It seems like there's two paths you could go down to do that. We can either make the data log up. We can either log that part of the data log, the part of the data log operation that we have that has. That we care about is never mind. Let me say that differently. We can either make what we call the data log part of something effectively transactional, which would presumably be more expensive than what we're doing now, or the alternative would seem to be that we find some other way to put an upper bound on how long a bucket replication could be stalled. And for example, you could scrub all the buckets in some periodic fashion, and restart anything that has stalled. I think that's sort of the short form, and it's sort of related to that. People have thought of other things. I mean, there are other strategies besides logging to Rados for the data log that you could undertake. You could do more. You could have a belt and suspenders sort of backup log kind of concept, for example. That's fine, but it doesn't. But it doesn't solve it by itself. It doesn't solve this sort of problem, but it narrows it a lot. So that's the topic.
We actually have evidence that this is happening.
Oh yes.
We should fix that then.
Well, okay, but those are the two proposed. Those seem to be. What I'm claiming is those are the two paths you could go down to solve it. Do you agree, or can you think of others?
I mean, I'm not certain if that's a correct description of the issue. Aren't we getting transactionality from Rados itself? Like, if we do it right, then either the right succeeds or the right fails. Like.
Okay, hold on. So yes, either the right succeeds or the right fails, but the delete of the object or the storing of the object or whatever it is has hypothetically already happened by this point.
Right, but if the But if the write fails, like there are two things that can happen. It's either a bug, and we should fix that, and I'd like to know about it.
Sure.
Or like Rados doesn't like currently in RGW, writes don't time out. Like things should either return success or they should return an error because there was an error. If the OSD up and died,
I totally agree. I totally agree with that.
Understanding of how Rados works is that we would either.
I stopped hearing you.
Is that we would either like never have the operation complete and just keep retrying it, or like I mean, I guess we could have something happen if RGW crashes right before ready to death.
Precisely. I mean, as long as I mean, from the point of view of consistency, once you admit that there's, which is not, no, it's not an admission, but once we agree that there's a race between committing the actual ingest and then recording this trace, we agree that there's a window for inconsistency.
All right, so we can have RGW crash between one and the other. I guess that's something that can happen. I don't think the OSD crashing should necessarily cause it, but maybe it does.
I think there are a variety of different cases, but we can just take we can call if you just say it doesn't matter what it is. I mean, there's other things that can do it, but it does. But it certainly is infrequent. I'm not saying this to shame us, but I think we need to bound this problem.
All right, so I think that actually is correct. Like we can have an RGW crash. I do kind of like the idea of having a periodic sweep that goes along, like maybe at idle times, and sort of does the equivalent of bucket sync run on all the buckets.
Yeah, I think all it needs to do is put an entry in the error log if it finds something odd, and then that'll or write a data log entry, or sorry, in this case.
So the data log entry would be stored on the source zone, and I think the recovery would be happening on the destination zone. So I think the error repo is the right place to do that. The error repo is what the destination uses to track things that it needs to retry.
Why wouldn't the source zone do it? I mean, all zones that can originate changes would presumably do this. It seems to me like the source zone would do this. Why would it be the destination? Maybe I'm not seeing maybe I don't know how we would detect it.
The destination zone is the one that's replaying the data log of the source zone and tracking its own sync status related to those logs. And so it's the one that knows what its status is. And so
I mean, one thing I have been thinking when you brought this up was that we already do have a situation where we, like when we do recharge and whatnot, after the end of resharding, we just write one entry per bucket shard to every shard in the data log. And I'm wondering if we could, we actually could do it on the source zone just by having a timer for like every 10 minutes or every 30 minutes or whatever. The source zone just goes through and does that one entry per shard thing.
For every bucket in the system, though.
Yeah, that's what that means. I mean, all scrum strategies would look like that in some sense, but if we have to whatever we come up with could potentially be very expensive. I mean, so I haven't assumed that it would be happening close to the limit of latency.
Like, yeah, I mean, I don't know how often, but it does seem like we could. But it does seem like doing that thing where we do the write an entry for every shard thing that we do after the end of reshards. Actually, on a periodic basis, might be the lowest effort and least complicated way to do it.
I mean, if you said, I mean, if the typical period was something like a day, I can't imagine enough buckets that would make that painful on a system large enough to contain such a count of buckets. Possibly you could do better than that. I don't know.
So I
Um,
think I like the scrub strategy the best, where we would only trigger retries on things if we identify that it's behind.
So you think we can reliably do that? Because I like that too.
I mean, can we reliably identify that something's behind if we've missed a data log entry?
Right. So if there are no marker updates on the source, then destination cannot know if it's behind or not.
So I'm imagining a scrub that loops over all buckets in the system and compares their sync status with the source zones. And if any are behind, then it adds it to the error repo.
So Casey, just correct me if I'm wrong. So if there are no data log entry, then the sync status on the source zone wouldn't update marker, right? It will still be on the previous marker.
So maybe because
sorry, go ahead. Yeah.
Anything that you want to write in the data log, can fail, right? Because this is the initial assumption that something wrong happened here. But on the destination zone, you can say that if you didn't get a record for a shard for a given amount of time, then you'll do the sync for this shard.
Well,
and then
you don't want to do that unless it's a very large window, right? So that's basically the same idea as atoms.
Right, but instead of doing that for everybody, or instead of the source will just tell to sync everything on some periodic time, and that could be, even if this time is long, there could be lots of shards. But if the destination knows that they didn't see anything for a specific shard for maybe a couple hours, then
I see. So this is like an optimized version of the visit everything.
Yeah.
Okay.
But doesn't it imply that you have to track events on every bucket shard in the system to know
at least every bucket? Yeah, I think that's right. So yeah, that's costly and not durable.
Yes.
So going back to Somya's point about not having data log entries, the scrub thing wouldn't touch data log entries. It would only be looking at the bucket sync status to see if the bucket was behind. And if bucket shards are behind, then we would add an error repo entry to sync that bucket shard.
Okay, thanks. Got it.
So yeah, I definitely agree that there's a gap, especially around crash consistency here, but I also agree with Adam that we should track down any other reasons that data log writes are failing.
Oh yeah, absolutely. I'm just looking for the semantic, the gap. This guy in this proposal or in this conversation, I'm not saying that you shouldn't fix all possible bugs to make the reliability as perfect as possible.
So regarding that, do we keep the data log in the same pool as we keep the bucket index? I mean, maybe things are failing because it's completely a different set of OSDs.
Data logs are stored in the log pool.
I think at a theoretical level, that's kind of a red herring. I mean, that might help you find the bug, but Rails is supposed to be reliable, so we have, at a theoretical level, we have to trust it.
So, to my knowledge, the only reason that we should be seeing errors from these writes in a, properly deployed configuration is if we exceed the retry count. Do you guys know if we've seen evidence of that in the logs?
We haven't actually looked closely on that part, Casey, but at least I think in the bug, which was filed upstream by Bloomberg, they did mention once, I think, that even after a retry, it fails when there was some races. I think that got fixed now, but yeah. Also, we retry for only a certain time period, right? Can we extend it, like if there is still a data log failure even after so many particular number of retries, we keep it in mem or log it and keep retrying after maybe with a longer time duration between.
Well, I think that kind of backup log idea is fine, and it makes it harder for it might be efficient as long as for certain class of things, but I don't think it eliminates the gap.
Crash, at least the crash. Yeah.
Yeah, I mean, I don't think a properly deployed system should ever actually run into the retries exhausted case. Like, probabilistically, maybe it can, but I'd be surprised. But I suspect it's very, very, very improbable.
Well, I think I agree with that, but I also think we should design. I mean, I think we should design the system so that it self heals.
Yeah, I think the case that RGW can simply crash after writing an object is a good thing to want to recover from, and I think that actually suggests that we do need a scrub analog specifically.
Okay, I don't have anything more to add to that, but I think that's something that's kind of where I thought too. But I'm glad that it seems like we have some agreement on that. We can talk about that as a thing to look at in the next cycle.
Sounds good. Any other thoughts here? How about new agenda topics? There must be more to talk about. We've gone a year since the last meeting. Okay.
Well, I understand people are talking about spinning up on doing the new coroutine asynchrony stuff. Is there anything to talk about it?
I think I need to rebase after. I think I need to not rebase, but I think I need to edit our current NeoRatus push request, since it does have what do you call it? Since it does have an incompatibility with the new version of libfmt.
Well, there's also review comments from Ilya.
I'm willing to accept one of those comments. He had 2 months to review it. I'm not going to do a bunch of formatting changes at the last.
Yeah, that was most of it, I'm afraid. Yeah, a couple of, hey, you can standard move this. I mean, I guess so, if true.
I mean, yeah, you can standard move this is, fine. I'll do that.
All right. Anything else for this call? Thanks, everybody. Happy New Year. See you next time.
Thanks, Casey.
Thanks you.
Thanks. Happy New Year.
Bye.
Bye, everyone.